Okay, so we're picking up from where the other video went. And it looks like my internet's super slow as usual. So we've already talked about these in the last video. So now I want to just talk to you about ethics, okay? That's standard 5, right? You've got that ethics sheet, so I think this is the easiest the ethics has ever been on the test. Remember, informed consent is really the most important thing. A person has to be fully informed. You can't just say, do you agree to be in this study? You've got to tell them what the risks are and what could happen to them. And it has to be voluntary. You can't coerce them, can't force them. They have to, you have to let them walk away. You also, as a participant, you have to know you're in an experiment. So they can't experiment on you when you don't know that you're part of the experiment. There's always that duty to protect the participants from emotional and physical harm. It can't be really dangerous or too stressful. So a moderate amount of stress or discomfort is permissible, but that's where the IRB is going to, Institutional Review Board is going to make that determination, okay? Remember, you can use deception. Students always want to say you can't, but you can use it if it's necessary for the experiment. You can't use it to trick them into being part of your experiment, but within the experiment, you can use it. But if you use deception, you have to debrief. So you have to go over what happened and the results and explain to the participants what was going on and why you did it after it's over. You've got to protect confidentiality, privacy of the participants. Their information can't be released, any of it, without their consent. Remember, there's special rules for animals. If you're going to do harm to an animal, you have to justify that there's some greater good, like the elephants on acid. There was really no greater good there. You also have to care for them humanely. So you have to feed them, you have to provide them proper shelter and all those kinds of things. And that is what you need to do for animals. Remember, they have their own rules, and you don't have to worry about deception and privacy and, informed consent with animals, all right? They don't have those things, okay? So Institutional Review Board, remember, that is just a group that's in any place they're doing research. So it's a hospital, it could be in a corporation, it could be in a drug company, for instance. All universities have it. Any place they are doing research, the IRB will approve the research and make sure that they're meeting those ethical guidelines, that the participants are protected. So that's the important ones for ethics. Make sure you have that handout, and that is very helpful for you. You guys have an OpenET test that we've never had that before. Here's a DBQ practice that I just think is worth talking about. So here you have a psychology teacher believes that attention in class is related to caffeine levels. She plans to do an experiment to investigate her belief. Please explain how the following would apply to her upcoming experiment. All right, independent variable. What's she going to manipulate here? She's going to manipulate the caffeine levels. So, if I am the psychology teacher, I'm going to give, half my class some Starbucks. Wouldn't you like that? Some Starbucks at the beginning of the class. And, the other half, they don't get any Starbucks, okay? And then my dependent variable is going to be, of course, how much attention they play. And that brings us to the second bullet point, the operational definition of the dependent variable. All right, so we have to measure attention in class. So we got to come up with a measurement. How can I measure attention in class? It doesn't matter how I do it, it's just that I'm very clear so that this can be replicated. So I'm going to say attention in class is, I'm going to measure how many times students look away from the teacher. Okay, so I'll have somebody observing the students and measuring how many times they look away from the teacher to something else in the room, whether it be their computer or their phone or another student. How many times do they look away from the teacher? It could be something else, by the way. It's just got to be something measurable. Null hypothesis. It's possible that it doesn't matter. Maybe I'm a really boring teacher, and even if I give half my kids caffeine, then they fall asleep too. So I can find out attention has nothing to do with caffeine, and so it's just I'm boring. Hopefully not. All right. This could also be a correlational study because they're looking at relation. When you see it is related, so, as caffeine levels go up, so does attention in class. We're looking for correlation there. So just keep that in mind as well. What's an ethical consideration? Can I jazz my kids up on caffeine just to keep their attention? So caffeine is a psychoactive drug. Is it ethical for me to give them caffeine? That could be something. Also, I've got to get informed consent for kids. I'd have to get it from their parents. So that would be another ethical consideration. I can't do physical harm. So is giving them caffeine potentially going to harm them? But I think always, when you're looking at ethical considerations, always go for the consent issue. A confounding variable, what could confound this study? Something that is going other than caffeine levels that are going to affect my attention, the attention that's paid in class. So you could talk about me being boring again. I'm sure you're enjoying that. But you could also talk about, maybe that it's going to depend on how much sleep everybody had the night before. So if everybody, if people didn't have good sleep, then even if they had caffeine, they might still be sleepy. So that could be one. Okay. And then a skewed distribution. If I have a lot of sleeping students, then that can cause a skewed distribution. If I have a lot of high scores of looking away, that would cause a skewed distribution. And remember, with a skewed distribution, the best measure of central tendency is the median. So we'd be looking at the numbers, seeing, and then get the skewed distribution that way. Okay, that was not a very good answer, but that's all I got today. Okay, what kind of skew is this picture? This is from a review that I did before, and I'm just like, I want you to look at these. All right, so you can always pause me and try and decide what kind of skew is pictured below. Remember, look where the tail is pointed. Here, the tail is pointed in a positive direction. So this is a positive skew. What is the number, or what is the mode of the following set of numbers? Okay, remember, you can't use a calculator, not that you need a calculator to calculate mode. Mode, remember, is the most frequently recurring number. So if you look in this set, there are 3 8s, and so the mode is 8. There's 2 9s, 2 5s, and if you find that there are 2 numbers that there are 2 of, and you're like, well, there's 2 different modes, you've miscounted, okay? There's 2 12s also. So just double check that. It's gonna be the most frequently recurring number in the mode. All right, what's the range? Remember, with the range, you're going to take the highest number. Here it's 106, and you're going to subtract out the lowest number. What's the lowest number? It looks like it is 5. So 101 is going to be your range. I hope that's right. It looks right. All right, then what is the mean of the following set? This one also no calculators. So you're going to add up these numbers. 50 and 25 is 75, and 75 is 150, then 100 is 250, and then 375, and then 525, 550, 560, and then you're going to divide that. Hopefully that's right. You can check me. I'm sure you got your calculator out. 560, and then you divide it by 1, 2, 3, 4, 5, 6, 7, 8. So you take 8 into 560, and your mean is 70. Okay, so look, I did that without a calculator. That's pretty good for me. Okay, what type of correlation do you see in this scatter plot? Okay, so we see a pretty good tendency of a line, all right, and it's headed in an upward direction. So that's going to tell us, when they're fairly tight, it's going to be moderately strong, positive correlation. Okay, so this is probably, somewhere in the 0.75 to 0.8 range. It's pretty good correlation. So that's pretty strong, positive, because it's heading up, positive correlation. All right, Lily scored a 145 on an IQ test with a mean of 100 and a standard deviation of 15. Remember, it's IQ test They're not going to tell you that usually. I'm not sure why I did in the slide. What is the z-score? Okay, so we know that she's got 145. Well, 100 is the mean, and so 115 would be a z-score of 1. 130 would be a z-score of 2. Add 15 more, 145. That gives you a z-score of 3. It's a positive 3. If it was negative, we'd be taking that 15 away. Okay, so Lily's z-score is positive 3. What is the median of the following numbers? Okay, we are going to line up those numbers and in numerical order and find the middle. And so we're going to have 18, 29, 35, 42, 47, 52, and 55. That puts 42 at your middle. It's way easier when you write this down. Hopefully I'm doing it right. It's off the top of my head, but just put them in numerical order and then find the middle. On this one, there are 7 numbers, so your 4th number is going to be your median. Okay, so put them in order and calculate the median. All right. Oh, I can't read that question. Let me get out of here real quick and see. Whoop. What did I do there? I lost it. Okay, I don't know what the question is. Which shows the weakest correlation? All right, so we'll go back to present. So which of these scatter plots show the weakest correlation? Well, that's pretty easy. I think I moved the dots on it. So it would be C. Ta-da! It would be C because there's no correlation there. But remember, when you see a bunch of dots that have no indication of a line, like they're headed up or down, then that is going to be a very weak correlation. Okay, so just keep that in mind. This is a good example of correlations. You see the strong ones, and you know what's negative. D, E, and F are D and E are negative. A and B are positive. C is also, or excuse me, F is also positive. Don't worry about the curve. I don't even know what that is. We don't have to know that. I don't know what that is. All right, which scatter plot shows the strongest correlation? Haha, this one doesn't have the answers visible. On this one, the answer is strongest negative. Oh, I almost got tricked on that. That's E, okay? So we only have 2 negative correlations there. So D is negative, E is negative, right? Because the line is headed downward. That's indicating a negative correlation. Remember, negative is not good. It's not bad. We're not using judgment, okay? It's heading downward. That's a negative, and that means your variables are moving in opposite directions. Okay, and E is a strong correlation. D is not a bad correlation, it's just not as strong because the dots aren't in a nice tight line. The tighter the line, the closer to 1 if it's a positive correlation, and the closer to -1 if it's a negative correlation. A and B are positive correlations. When you compare those two, A is a much better correlation. The dots on the scatter plot are in a nice tight line. That means that is a strong correlation. So I think that's it. I just wanted to give you a few samples. I'm worried about the correlations. I'm worried a little bit about research, or about the statistics part. So hopefully that is helpful to you. If you have questions, let me know, and good luck on your test.